Hey everyone, welcome. Today, we're diving into a topic that's, well, absolutely essential for any software engineer, especially if you've got technical interviews on the horizon. All right, let's get right into this masterclass on linked lists.
So let me ask you a question. What's that one data structure that can make even the most seasoned developers start to sweat a little bit in a coding interview? You know the one. It comes up all the time, and it's famous for tripping people up if they're not ready. It's all about juggling those pointers and making sure you don't lose track of everything. Any ideas?
Yep, you guessed it, it's the dreaded linked list. But here's the thing, and this is the real secret. You don't have to panic. The key to absolutely crushing these problems isn't about cramming dozens of solutions into your brain. No way. It's about really, truly understanding a handful of powerful core patterns that you can use again and again. And that's exactly what we're going to unpack today.
So yeah, let's call it what it is. The interview gauntlet. But hey, every gauntlet has a secret path, right? We're about to give you the blueprint for success.
The material we're drawing from, the Linked List Algorithm Masterclass, does this brilliant thing where it boils down this huge topic into just 5 core problems. Seriously, if you can nail these 5, you'll be ready for pretty much any linked list question they can throw at you.
All right, so let's check out what these 5 pillars actually are. Think of these as the absolute must-know problems that are going to build the entire foundation for you.
Okay, here we go. We've got mastering the reversal, detecting a cycle, finding the middle, removing the nth node, and merging sorted lists. Each one of these isn't just a random problem. It teaches you a critical pattern. Now, to really show you how this whole pattern-based thing works, we're not just going to glance at these. We're going to do a real deep dive into the very first pillar, which is, you could argue, the most fundamental of them all.
And that is, of course, reversing a linked list. We're talking about taking a list that flows in one direction and literally flipping it on its head, so every single pointer goes the other way. All right, so here's the challenge for you. Imagine you're given the head of a list. How would you actually reverse it? I want you to really think about this for a second. Go ahead, you could even pause. If you take a node and change its next pointer to point backwards, how do you keep from losing the rest of the list? That's the real puzzle, isn't it?
Okay, you back? Got some ideas cooking? The big aha moment here is that you just can't do this with one pointer. It's impossible. The magic, the real key, is using 3 pointers that work together in this perfect little dance to safely rewire the whole thing without breaking it.
So let's break down the steps of this dance. First up, you need a previous pointer. It starts at null, right? Because the new end of our list isn't going to point to anything. Then you have your current pointer, which is just going to walk down the list, starting at the head. And third, and this is the most important one, you have a next_node pointer. Think of this as your safety net. It saves the link to the rest of the list before you change any pointers. After that, it's just a loop. You make current point to previous, and then you just shuffle all 3 pointers one step down the line. That's the whole move.
And this is what that logic looks like when you turn it into actual code. Check it out. On the left, we've got the C++ version, and on the right, Python. You can literally see our 3 dancers, prev, cur, and that crucial bookmark, the next node. That while loop, that's the dance routine we just walked through. You save your spot, reverse the pointer, and then move everyone forward one step. It's just so clean and efficient.
And that's it. Just like that. You get it. See? It's not some kind of dark magic. It's just a logical, repeatable pattern. You have now officially unpacked the logic behind one of the most common interview questions out there. I mean, how good does that feel?
So what's so cool about this is that the same kind of thinking applies to the other pillars. Let's do a quick flyby of the core ideas for the other 4, just so you can see how this all connects.
Okay, next up, detecting a cycle. This one uses a beautiful pattern. People call it the tortoise and the hare. You have one slow pointer that moves 1 step at a time, and a fast pointer that jumps 2 steps. Now, if the list is straight, they'll never meet. But if there's a loop, the fast one eventually gets trapped and runs laps until it catches up to the slow one. It's such a clever trick to find an infinite loop.
What about finding the middle element? Are you starting to see a theme here? It's the exact same 2-pointer trick. When the fast pointer, hopping 2 nodes at a time, finally hits the very end of the list, guess where the slow pointer is? Bam! Right in the middle. It's just a perfect example of how one pattern can solve totally different problems.
All right, how about removing the nth node from the end? Come on, you know the answer already, don't you? It's 2 pointers again. This time, though, you give the first pointer a head start, a gap of n nodes. Then you move them both forward together 1 step at a time.
When the first one hits the end, that gap means the second one is sitting right on the node you need to remove. So simple. And last but not least, merging two sorted lists. Now, this one's a little different. It's less of a clever trick and more of just a really fundamental, straightforward process. You literally just look at the front of both lists, pick the smaller one, add it to your new list, and then move that pointer forward. You just keep doing that. It's a super clean, super important building block for bigger algorithms like merge sort.
And that brings us to the single most important point I want you to walk away with. Please listen to this. The goal is not to memorize 5 solutions. It's to internalize the 2 or 3 patterns that solve them all. I mean, think about it. We just saw how that 2-pointer idea, whether it's the tortoise and hare or the gap method, solves 3 of these 5 problems right off the bat. If you really get those patterns deep in your bones, you'll be able to solve problems you've never even seen before.
Because when it comes right down to it, this isn't just about passing an interview. It's about becoming a better, more thoughtful, more elegant problem solver. It's about building your toolkit. You've seen the blueprint, you've seen the patterns. So the only real question left is, which pattern are you going to conquer next?